Hey everyone, it's JD. I want to go over a second way or an alternative way to do these 3-point test cross problems. Primarily because I was having trouble following the method of drawing the lines um, between the different loci and making sure that I always get the right answers. So the minimum information that we can be given, I guess, to solve these is the phenotypes, which we have on the left here, and the observed numbers of that phenotype. So I have that here. This is from the problem that was given in lab. And then here's the way I solve it. We look and we're doing a 3-point test cross, which means we have to have one parent, this one, that's heterozygous, and the other parent is homozygous, recessive. So, and these could, instead of alleles, you could have like P star P to say that, or P star P to say that it's wild type. You could do it anyway here, but I like to do the big capital letter and lowercase because that's what I'm used to most of the time, I guess. So we are looking at P, D, and B. And we do this the same every time when it's a three-point cross. So there are 8 possible ways that P, D, and B can recombine or can be altered, matched up together. So we're going to write all those down. And the way we do is we just start with P, start at the first spot, and we write 4 capital P's, and do this the same way every time, and then 4 lowercase p's. So the first row you do 4, the next column you do 2, so we're looking at the D's now. And over here we do 2 in a row, and we alternate. Big D, little d, back and forth. And then we go to the third one, B. So, and we had 4, then 2, then 1, we cut it in half again. So now we alternate every other one. Big B, little b, big B, little b, big, little, big, little. Okay, now what this does is guarantee that we have all the possible genotypes for the gametes. And that's important because typically what we've been doing is going through and saying purple, dumpy, black, and then we've been trying to write the genotype for that. And that's harder for me because sometimes I might write something wrong. So this way, I match these up, and I remember that this would actually be big P, little d, and little b here. And that's because the other parent is homozygous recessive, but there's no point. So if you see a lowercase letter in the female here, then you know that it must be the mutant type. And if you see a capital letter, it's the wild type. So this first one that we're looking at is capitals all the way across, so it's wild type all the way across. Wild type at P, wild type at D, and wild type at B. So then we just look up in our table and find the wild type. It says 409, so we write down here 409. And we do this for all of them. This second one has 1 lowercase, the B, and lowercase b means black, so we look for the black. Black is here, 14. 1 lowercase at D means dumpy, so we look for the dumpy, 164. Dumpy and black, so we find that, 29. Purple only, find purple, 24. Purple black, 148. Purple dumpy, 12. Purple dumpy black, top 1. So then I just take a look. Yes, I've done all of them because I drew a line across, so now I know I have all of the different possible combinations here for the gametes. And there's always going to be 8 of them. And if you do that order, start with 4 capital letters, 4 lowercase, then the next column, 2 capital letters, 2 lowercase, then 1, alternate back and forth, you'll get all of these in order correctly. The next thing we want to do is circle the parental parent type, the parental gametes. So we find just the 2 that are the highest number. So 409 and 413. And then we mark those. Those are parental. And what this does is give us our linkage phase. So now we can go right up here and actually write our parent linkage phase must be this. This is not the correct order necessarily. It could be, doesn't have to be, but it is the linkage phase, and that's important. So the next thing that we do is we have 3 columns off to the right, and we write the possible ways that we can get recombinations. So since we're dealing with P, D, and B, we could have a recombination between P and D, we could have a recombination between P and B, or we could have a recombination between D and B. Okay, so let's start with this one. We're going to start with P and D. What we do is look above to the parent linkage phase, so we're looking right here, and we see that the parent's gametes can either be capital P, capital D on top, or lowercase on bottom. So if we look over here at our column and we find both capitals or both lowercase, we know that it's a parental type, and we're going to mark it with a P. If it's not capital, so it's capital lowercase or lowercase capital, we'll mark it with an R and put a circle around it. All right, so the first one, since it is the parent, we know it has to be parental. The second one, capital P, capital D, we see here. So that's parental. Capital P, lowercase d, must be recombinant because they're different. Next one, recombinant because the P and D are different. P and D are different here, recombinant. P and D and diff are here, recombinant. And then for the bottom 2, they're all lowercase, so parental, parental. Now, this is important. There must be 4 parents, 4 parental types, and 4 recombinant types. For each one of these, for PD, PB, and DB, there's always going to be 4 and 4, and that's a good way that you can check yourself and make sure that you've got them all. All right, so then P to B. Well, we look at our parents. Again, capital P here, capital B here, lowercase here. So if they're the same, all caps, or the same, all lowercase, it's going to be parental. So the first one is P and B are both caps, so parental. Second one capital, 1 lowercase, so this is recombinant. This one is both capitals again, so parental. Recombinant. Recombinant. Parental. Parental. I messed up. Parental, I need to circle these ones. And then this next one, lowercase b, lowercase p, capital B, so that's a recombinant. And then both lowercase, so that is parental. Okay, again, 1, 2, 3, 4 recombinants, 4 parentals, we're probably good. Okay, now D and B is the last one. So for D and B, we've got the same thing. If they're both capitals or both lowercase, because, and it's not always that, what we have to do is look up here at the linkage phase that we just drew in red. Whatever it is up here, that's what we look for in our orange over here on the side. So D and B, like the DB linkage phase, is capital DB. If it looks like either one of those, it's parental. So let's go through there. So parental, recombinant. This one is recombinant. 2 lowercase, so parental. Two capitals, so parental. Recombinant, parental. All right. So now the next thing that we're going to do is total all of our columns. So the first column we're going to total is right here, the very first one. We're going to add everything together, 409 plus 14 plus 164 plus 29 plus 24 plus 148 plus 12 plus 413. That gives us a total of 1,213. All right, now, in these next ones, all we're going to care about is the recombinants in each column. So For the first one, the P and D, we're going to add this one, this one, this one, and this one. So we're going to add 164, 29, 24, and 148. So 164 plus 29 plus 24 plus 148. And that's going to give us 365. All right. The next row, P to B, we're going to add this one, this one, this one, and this one. Only the recombinants. So 14 plus 29 plus 24 plus 12. That gives you 79. Okay. Then this last column, this one, this one, this one, and this one, add those up. 14 plus 164 plus 148 plus 12. That gives you 338. Next thing we're going to do is take each of these three columns and divide them by the total. And then right below it, we're going to write the answer. So 365 divided by 1213, that equals, and here's the way we're going to do it. So that equals 0.3009 something, something, something. Just go ahead and multiply it by 100 in your head. So move your decimal point. So it's going to be 30.1-ish. So we're going to write it that way. 30.1. 79 divided by 1213. 6.5. 338 divided by 1213. 27.9. Now, let's go back to here. I'm just going to delete this now. What I like to do here is now come up with my order for my map. So I start out with whichever one recombines the least. So P and B must be the closest together, and we've determined that it's 6.5 centimorgans. Then let's see, the next one is going to be, let's see, P and D are the farthest apart, so D has to be on this side. And between B and D, we've done that here in its third column, and we've determined that it's about 27.9 centimorgans. So 27.9. And then for the distance between P and D, remember we don't take that. Instead, we add these two together, 6.5 plus 27.9, and it's about 34.4 centimorgans. Okay. Now we have the order, and this is what's important. So now we have the PBD. That's the order that they're in. Up here, we already had the linkage phase, right? So we already had the linkage phase. And now we're just going to rewrite it in the correct order, PBD. So on top, it's all capitals, PBD. On bottom, it's all lowercase, P, B, D. Okay, now we can delete that. We know that this is not on the linkage phase, but also in the correct order. So we know that B is in the middle. We have our map distances here. The next thing that we could do, he usually asks us to label the recombinants and the double recombinants and the single recombinants. So what I'm going to do, and this one has a trick to it. So to find the double recombinant, the first thing you do is look for the one that's the lowest. You can see that it's 12 right here. That's a little bit large. You can see that it's 12. And so this row with the 12 is definitely a double recombinant. So that's, or not, I shouldn't say definitely, but most likely that's a double recombinant. Now, rather than just picking the next one that's lowest, instead what we're going to do is look at where the two Look at where these R's are for the recombinants. And then we look above to our table and we find the one that matches, which is right there. Now, probably almost every time it's also going to be the next one that's also the lowest. But depending on the recombination frequency, you might have a single recombinant and a double recombinant that are similar numbers. So it might not work out perfectly every time, but if you find the lowest one and assume that is the double recombinant, then what you do is you look in your columns here and you find the other one that matches the recombination positions. So we're going to highlight that. So these two are double recombinants. And the only thing that's left, if you have two parents and you have two double recombinants, that means everything else, so all of these in the middle, these are all single recombinants. Single recombinants. And the reason I don't get hung up on the number of circles for a recombinant is because this single recombinant has a circle here and a circle here. So, and that's because of the way this is written. So completely ignore the number of times that it's circled. Find the lowest one, make that a double recombinant, then match, again, match the locations of the circles. So this and this, and this and this. So those two go together and those two go together. And then all the others are going to be single recombinants. So that will let you solve every question except for doing a goodness of fit on this, which would be a different video. But that's how I solve them, and I think it's a lot easier this way. So maybe it helps you, maybe it doesn't.